In this video, we're going to discuss how to construct a histogram. And what a histogram is, it is a graph that displays data from frequency distributions using contiguous vertical bars of various heights that represent the frequency of a given class. Now, the only time that our bars will not be connected is if a class has a frequency of 0. So here's an example of what a histogram would look like. Essentially, it is a bar graph. Now, but the bar graphs are connected within the picture. I do have a class down here circled that is the ages between 80 to 90. This is the only time that you'll not have a bar and where the bars will be disconnected from each other. When you make your graph, you'll have an x-axis and a y-axis. We need to put appropriate information on those axes. First, we'll start with the horizontal axis. The boundary numbers that are from our frequency distribution will be used to label that axis. Second, we need to evenly space those boundary numbers out so that the width of our bars will be the same. And then third, we need to make sure that we label the axes. Look back up at our example here. Age was used for the label on the axes. For the vertical axis, our frequency values will go up on the vertical axis. We always start our vertical axis at 0, just like the origin. And then third, make sure that you choose an appropriate scale. Doesn't matter what your scale is going to be, as long as it is appropriate to the data that you're trying to present on hand. If you're going to go up 2s, you can go up by 2s. If you want to go up by 10s, you can go up by 10s. You can go up by decimals. It just depends on the data that you have. So we're going to take data from a previous lesson, and we're going to make a histogram for it. In the last video, we went over the Electoral College of 2016. Here's the grouped frequency distribution that we had throughout those states. So we'll go ahead and make our axes. We're going to start with our vertical axis. We know that that's supposed to be the frequencies. The highest frequency we have is 30, so we don't want to go too high. Where we get into the 50s and 60s, that'll make our bars very short, so we're going to expand this out as much as we can. What I'm going to do is go up by 5, so I have my bars stretched out as much as possible to represent our data. Every line represents 5, so this is pretty consistent. We're not going to have bars that are different lengths. Next, our x-axis. We have to have a label. This is supposed to represent our electoral votes. Then we borrow all of our boundary numbers and evenly space them out for the labels on the x-axis. Now what I will do is go from the first class. So what I will put here for this bar will come from our first class within the frequency distribution. We have a frequency of 34, so I will draw a vertical bar that goes up to 34. The bar will go from our lower class limit to the upper class limit, or the boundary limits. And then from there we jump down to the next frequency. But when we draw our bar for this frequency, it has to be connected with the previous vertical bar. There's not going to be a gap between them. So we had 11 for a frequency in the class of 11 to 18, so that bar goes up to 11, and it stops at 18.5. We go to the class of 19 to 26, there's a frequency of 2, so that bar will go up to 2, and we will stop that bar at the upper class boundary for that particular class, which is 26.5. The next frequency for the class of 27 to 34 is also 2, so that will repeat. It'll look like a flat line. And then we have, for the class of 35 to 42, there is 1. And then for 43 to 50, there are no frequencies in there, so there will be a gap between this bar and the next bar. When I go to the class of 51 to 58, there is 1 frequency, so I have to put another bar of 1. And there you have a histogram for our grouped frequency distribution that we had from our previous video. Next thing that we will look at is that frequency distributions take on different shapes. There are 7 different shapes that we're going to look at. The first one is called a bell shape, and the reason why it is called the bell shape is that if you were to draw a graph here or a line to best represent that, it takes on the shape of a bell. The highest point of this graph is almost directly in the middle of our distribution. So if it takes on a shape of a bell, then we will go ahead and call it a bell-shaped graph. The next one we have is called negatively or skewed left. People can get this confused because a lot of the data is to the right, but the reason why we're calling it skewed left is that although the majority of the data is to the right, there are going to be some data points to the left that are going to skew our numbers smaller than what the real data is saying to us. So this is skewed left. On the opposite side of things, there we have positively, or we call that skewed right. Although the majority of the data is to the left here, there are going to be some data points to the right that will skew our numbers a little bit higher than what they really are. So we call this skewed right. So when there's a few data points to the right, we call it skewed right. And when there's a few data points to the left, we call it skewed left. Also notice that we have that high point in the graph is not in the center. So even though it takes on somewhat of a bell-shaped graph, that bell-shaped is skewed to one direction. Another type of graph we have is called a J-shape. This should be more common sense here, because if you think about the shape that it would make, if you make a J here, the graph takes on the shape of a J. If it is flip-flop that, then we'll just call it a reversed J-shaped. Notice that it does look kind of similar to the graph that we have above here with the positively or skewed right type of graph, but the only difference is with the positively skewed, it goes up and then it comes back down, whereas on this, the graph is continuously just going up. There's not a point where it peaks and then it comes back down anywhere. The next graph we have is called a U-shaped graph. So there are two high points in the graph that obviously it would take on a shape that looks like a U. And the last one that we have is bimodal. Now, again, this is similar to the U-shape, but with the U-shape, there are two high points are at the very end and the low points are in the middle. Whereas on the bimodal, it starts low, gets high, gets low again, reaches another peak, and then eventually it goes back down. So there are 7 different types of distributions that you have, and they're not always going to be perfect, but it's easy to have some type of name to represent for those graphs. So if somebody asks, what type of pattern are we following here, you can tell them that, hey, we're following a bimodal pattern for our data here. All right, so let's remind ourselves of all the data that we had from our electoral college graph here in this frequency here. What type of pattern does this graph follow? Well, we see that there is a high point at the very beginning. The data points are continuously going down and always going down. So we would either be looking at a reverse J shape, or it could be a skewed right graph. Well, it's not a skewed right graph because there's not another bar over here to the side where the graph goes down. So therefore, we're going to call this a reverse J-shaped distribution. So there you have it, a video showing you how to construct a histogram and